I was so different when I was a kid, and so different now.
Really?
Yeah, very different. Okay.
Biology.
Yes.
Page number 101. Lipid synthesis on the isthmus endoplasmic reticulum. Synthesis of phospholipid. It happens on the cytoplasmic layer of isthmus endoplasmic reticulum, of SER. In the cytoplasmic layer of SER. Translocation of phospholipid philipase. Now, what is the philipase? See, this is the isthmus endoplasmic reticulum. This is the SER. Cytosolume. It's to produce a new phospholipid. But if I have, this is my layer. If I new phospholipid in this layer, because it happens on the cytoplasmic layer,
inside
the new one comes here. In this case, after some time, it will be much more longer than this. I should think that how can I prevent much more longer of the cytoplasmic layer compared with the exoplasmic layer.
Can you flip it?
Yes, and in this case the philipase come, take one of them here, cut it here, and after that it will be normal but much more bigger. It is the same size, it will be longer, then it will be equalized.
That's why it's named philipase, because you can flip?
Flip flop.
Okay.
Flip flop.
But this is the membrane of
isthmus endoplasmic reticulum.
Yeah.
This is the cytoplasmic membrane.
So okay.
And this is the exoplasmic membrane. Good?
Yes.
The philipase flip-flop the phospholipid from the born place to the other place to can equalize the size of two membranes. Translocation happens by phospholipid philipase.
Yeah.
But here we have a signal peptidase. Why peptidase? Because here we produce protein. Why lipase? Because phospholipid philipase. Why? Because we have produced here phospholipid.
Yes.
No, my question, what is the phospholipid?
Phospholipid?
Yes.
It's a lipid that consists of a phosphate group.
What is this?
This?
Propan.
Propan, yeah.
Propan,
yeah.
nol. Propan, diol. Propan,
triol.
What is the other name of propan triol? Glycerol.
Oh, glycerol.
Oh,
no, true.
Instead of OH minus, maybe
phosphate.
the root of the acid coming.
Yeah.
COO minus. Substitute instead of OH minus. This is the esterification. Alcohol plus acid. Again, this alcohol plus another acid. See, this is the reaction. OH from acid, H from alcohol go away, and again one ester formation. And one more carboxyl here. This is not triglyceride. So triglyceride. Okay, this is how do you pronounce it?
Triglyceride.
Triglyceride, but the exact pronunciation is triglyceride. Okay. Such like that. Okay, I always confuse which of them was I, which of them was E. The triglyceride is formed. The phosphotriglyceride, instead of this ester formation, instead of this R has the PO32 minus. It's synonym with PO43 minus. Not 2 minus, because one of the minus charges come here. It's a phospho and lipid. And you should be able to draw them. You know them? Okay.
Okay, can I try? So it has, are you saying it has like this?
Yes.
An H or
it's a R. R, a lot of other carbon.
Okay, so same.
O, C, double O,
and R.
R. Here is C, O, P, O. Perfect.
And the O there?
Yes, double O.
Double O there. And then a minus charge?
Yes.
Okay.
Double O. Yes, double O.
And these are the ester.
This is just one O.
Okay. Okay. And there's ester formation there.
This is ester. This is phosphoester.
Okay. Okay.
Now, transport to other organelle. This phospholipid is produced here to transport it to other organelle by the vesicular transport and sometimes by phospholipid exchange protein.
I have a question. So if the phospholipids are made like within the membrane of the smooth ER, then are they cut, like made as a vesicle and then transported?
Yes, it's like a vesicle formation.
Okay.
And then it's like exocytosis from smooth endoplasmic reticulum and endocytosis to other organelles. It's
Okay.
exactly like that.
So do they just cut?
Yeah,
They
what
just-
happened to your eyebrow?
What happened?
A lot of cutting. Your hair is lying and it's...
No, I haven't cut. They don't grow on mine. They don't grow here.
Vesicular transport, or sometimes by a phospholipid exchange protein. This is a protein. Can exchange the phospholipid. I don't know how. But these two mechanisms is important. I just know that.
Okay.
The teacher asks you how the phospholipid is transported out of the smooth endoplasmic reticulum, and you should say by vesicular formation or by exchange protein.
Exchange protein.
Exchange protein.
How is the
formation.
exchange protein?
I don't know.
Okay.
I really don't know anything about that. Just I remember exchange protein.
Okay, but I can say that the phospholipid, it's cut like in the membrane and then exo.
No.
Is it like that?
It should be some thing like that. Some phospholipid attached to the protein. The protein is transferred to somewhere else, and then cut the lipid, and the lipid goes away.
Okay.
It should be the similar story, but I don't know the exactly. I cannot say about that. Synthesis of steroid. No, the question is here: how many steroids do you know?
I know vitamin D.
No, vitamin D is a lipid soluble vitamin. Vitamin is
Oh,
a steroid derivative.
Cholesterol.
Cholesterol, yes, but the cholesterol is also a steroid. Is a mother of all of the steroid cholesterol. Steroid hormone is
Testosterone,
Yeah.
estrogen, and all that.
testosterone.
Estrogen, progesterone.
Okay. 6. I need
Oh.
cortisol,
Cortisol,
aldosterone,
aldosterone.
and androgen.
Okay.
All of them happens here. Now the question is, who is the mother of the cholesterol? Who is the mother of cholesterol? Esterone. What is the structure of esterone? You should know. This is here.
Okay. I do know. I don't know estrogen. So steroids are made of cholesterol.
Esterone structure.
Sterone structure.
You should know also it has a 4 ring, A, B, C, D, 3 6-member ring, 1
That's
5-member
steroid,
ring.
right? That's a steroid.
No, this is the mother of a steroid.
Okay.
This is the backbone of that.
Hmm.
The steroid is much more difficult than, for example, progesterone has a 2 OH here, has a 1 5 and 1 6 carbon
Yeah.
here. You learn it later. Just you should know this.
So
Put your eraser here.
okay.
You should know this structure. You should know this structure. You should know what is the choline and what is the phosphate group here, and you should also know what ceramide is sphingosine and fatty acid.
Hmm.
And you should know the number of the bond and the type of the bond between starch alpha 1 to 4, beta 1 to 4. You know what is the difference between alpha and beta?
Yes, but alpha in alpha the OH group is down.
Down, and beta is
Is up.
up.
But I have a question. So it's cholesterol and no, sterone and then cholesterol
Esterone produce cholesterol.
and cholesterol.
Cholesterol produce
Steroid.
testosterone
Okay. But where is the steroid then?
and progesterone. These are the steroid. Progesterone. These are the grandmother, grandfather.
Okay.
Okay, progesterone, and from them the other is produced. A lot of other things. These
Alright.
are also the grandmother.
Okay. So steroid. Okay. All right.
And who is the mother of esterone?
Um,
Isoprene. Do you remember the structure of isoprene in chemistry?
oh yeah.
2-methyl 1-antiributadiene. Isoprene.
Okay.
5 isoprene. No. 6 isoprene. 6 multiple 5 is a 30 carbon. This is 30 carbon, and this is a 27 carbon. And you learn it later. These are much more or a smaller derivative.
Okay.
No, it's also finished. The secretory pathway, protein glycosylation, and sorting.
Sorry, can I just see where we are now? We are in.
We finished the rough endoplasmic on topic 53. It was topic 53.
Okay, what is the
rough.
mechanism of action of steroid hormones?
The mechanism of action of a steroid hormone. Good question. It's here. Steroid superfamily protein, and it's here. Some steroids here. All of the steroid hormone has a receptor inside the cytoplasm, like a glucocorticoid. Glucocorticoid come here and like that.
Okay.
All of them has a cytoplasmic receptor. Why?
Why?
Why? Because they are lipid soluble. They can penetrate through the cytoplasmic membrane. Now we are in the topic 54. Good?
Glycogen. Yeah. Glycosylation. I think that's MRT question what means or something like that. So oligosaccharides that
I
bind
need
to.
a bit rest, please.
Okay.
5 minutes.
Okay.